Hi guys, this is question 10 on the AS Unit 1 Summer 2019 WJC past paper. I've been asked to solve the following simultaneous equations: 3 to the power of 3x times 9 to the power of y equals 27, and we've got 2 to the power minus 3x times 8 to the power minus y equals 1 over 64. So this is my equation 1, this is my equation 2. We're going to look to, with this question, get the bases the same number, and I can see that because I've got factors of 3 here with 9 and 27. So I want this 9 to be a 3 and I want this 27 to be a 3. So I can make 9 a 3 because I know 9 equals 3 squared. And looking at my 27, I also know 27 is 3 cubed. So I can just replace my 9 with 3 squared and my 27 with 3 cubed. So I'm going to rewrite my question 1. I'm going to have 3 to the power of 3x times 3 to the power 2y, and that's just using, this I've got from here, and I've got equals 3 to the power of 3. And I've got that from here. Okay, and now using my indices laws, I know that AM times AN, that is equal to AM plus N. Okay, so I'm going to have 3 to the power 3x plus 2y. And that equals 3 to the power of 3. Awesome. So now I've got my equation to the same base. So my equation is all to the base 3. I can equate my indices. So what I've now got, I can make equations just for my indices. So I've got 3x plus 2y equals 3. So that's my first equation. This looks a lot better and we know what to do with this. This looks familiar. Okay, so now we're going to look at our equation 2. Equation 2, we're going to look to get things into base 2. So we're going to make this 8 a 2 and we're going to make this 64 a 2. So with 8, I know that is 2 cubed. And with 64, I'm not too sure. I know it is 2 to the power 5 or 6. I'm just going to double check on the calculator. So I'm going to do 2 to the power 5, that's 32. So 2 to the power 6 is 64. Okay, so I can rewrite this as 2 to the minus 3x times 2 to the power minus 3y, and that minus 3 has come from 2 cubed, equals 1 over 2 to the power 6. Another one of my indices laws is 1 over x, and I know that is x to the power minus 1. So that means I can bring this 2 to the 6 up, so I know 1 over 2 to the power 6 is just 2 to the power minus 6. Okay, so I can sub that in, so I've got 2 power minus 3x times 2 to the minus 3y equals 2 to the minus 6. And then I can sort this left hand side out with my times in the indices law. So I know I'm going to have 2 to the power minus 3x minus 3y equals 2 to the power minus 6. Now I can equate my indices. I'm going to have minus 3x minus 3y equals minus 6. So that was all because we can do this because we've got the same base. So nice. So we've got our two equations, which I'll write out again, or I'll copy and paste. So I'll take equation 1, looks good, and then equation 2 underneath it. Okay, and now it's just a case of simultaneous equations. So I'm just going to do, I got 3x minus 3x, so I'm just going to do 1 add 2. And my 3x will cancel out, and I'll be left with minus y equals minus 3. So I know y equals 3. Using y equals 3, I'm going to put it into another equation. So I'll reuse my first equation. So I know 3x plus 2y equals 3. So 3x plus 2 lots of 3 equals 3. I'm just going to minus 6 because I know that's 6. So 3x equals minus 3. So x equals minus 1. Cool. And now we go on to part B. And we're told that log a3 plus log 2 log a x minus log a x minus 1 equals log a 5x plus 2. Okay, so this is going to be using log laws. So I think the first one I'm always going to look at is this multiple. So I can change 2 log ax to, that can be this, that's the same as log ax squared. Nice. So I've now got log a3 plus log a x squared minus log a x minus 1 equals log a 5x plus 2. So my game here is just to put it all into one log on the left hand side and one log on the right hand side. I'm going to do the same, like equating my indices, but we're just going to equate everything in the logarithms. So we're going to have, so my log laws, so I've got 3 plus, I've got log a3 plus log a x squared, so I can change that to log a, lots of 3 times x squared. Okay, and then I can do minus log a x minus 1, which equals log a 5x plus 2. Okay, so now using my minus log law, so I'm going to have log a, I'm going to change 3 times x squared just to 3x squared all over x minus 1, and that equals log a 5x plus 2. Okay, so now I have a log of log a, log to the same base on both sides. I can now equate what's inside them. So I've got 3x squared over x minus 1 equals 5x plus 2. Okay, so I think what would be best is to multiply by this x minus 1 to get it off the denominator and make it look a bit nicer. Okay, so I'm going to have 3x squared equals 5x plus 2 times x minus 1, and then I'm going to have to expand these brackets. So I'm going to have 3x squared equals 5x squared minus 5x. I've already done that. Plus 2x minus 2. Okay, collecting like terms, so I'm going to have 3x squared equals 5x squared minus 3x minus 2. And what I'm going to do is I'm going to take this 3x squared to the other side, just so I'm keeping a positive coefficient of x squared. So minus 3x squared both sides. I'm going to have 0 equals 2x squared minus 3x minus 2, and we can see that we've got a quadratic. So let's factorize. So we're going to have 2x plus a plus b. So here we go. I'm going to have plus little a here plus b. And so my two equations. So that's what I get, minus 2y times a times b equals minus 2. And then I'm going to have 2b plus a equals minus 3. Nice. Okay, so I know I'm going to have a negative and positive, or positive and negative. So I'm thinking it's going to be 2 and 1. It's just because we're going to have factors of 2. And we know 2 is prime, so it's going to be 2 and 1. So if I had 2 lots of positive 2, 2 lots of minus 2 plus 1, that would give me minus 3. And then minus 2 times positive 1 will also give me minus 2. So I've satisfied both of these red and green equations. So my factorizing in my brackets, I'm going to have 2x. So little a was 1 and little b was minus 2. So I'm going to have plus 1 and then x plus b, which is x minus 2 equals 0. So I now know that x is either a half or x is positive 2. Okay, so I have a slight problem here. Sorry, this should be minus a half. And my problem here is this minus a half. So if I was to draw out my natural log graph, I have something. My important point is here, and that's the 0, 1. Sorry, that's 1, 0. And what happens is my graph never crosses the y-axis. There's an asymptote here, and it just goes to negative infinity. And this is my log graph, and it's something like this. So here, this is the problem. So because it never goes into the negative region, it never crosses this line. It never goes past 0, so I cannot have a negative value for x. So it just means that my x equals 2. So this is going to have to be my answer, because that will lie somewhere, I don't know, about here. And so I know that x equals 2. Hi guys, if you found this video useful, please consider liking and subscribing. All written notes will be available in the description. Best of luck with all your exams, and I'll see you in the next one.